Hey guys, it's Tristan here. I just wanted to give you a relatively brief introduction to working with normal maps. This is a general kind of understanding video, so it'll cover some concepts about how you handle normal maps to make good results, but also cover context about how you would actually create normal maps in Maya. So a lot of more advanced tools, such as Substance, don't require the use of manually generating normal maps through a specific tool chain and allow you to basically just drop in a high poly and a low poly and automatically create it. But this, we're going to talk about it in the kind of old school way so we can kind of see how it works and some of the specifics. So, all right, let's just go ahead and jump into it. So I actually have two assets here. My two assets are my low poly, which is basically like a low resolution version of this floor asset that I'm creating. And then, let's see, try to get that. So that one looks basically something like this. And then I have my high poly version, which is much more complicated, which is a model that I made in ZBrush. So, okay, in general, there's a few things to watch out for when we're doing stuff like this. But I want to show you just essentially how things would come out if we just kind of did this in the most naive way, and then talk a little bit about what the outcome is. So you'll notice here right now that the top of this model is all part of the same essentially smoothing group. That's how you want this to be, but for right now, I'm actually going to undo that so that just so you can see what happens if we do not have that object set up that way. So I'm just going to go ahead and go to Mesh Display and harden edge, and actually I think I might just go Mesh Display set to face just to make sure that it actually sets it to exactly the faces, which is often what that model will look like when you're just working on it from scratch. Then I also want to make sure that this model is directly 100% overlapping with my high poly model. So I'm going to see that I have my translate is currently negative 447. I want to make sure that that's 0. I'm also going to make sure my high poly is 0 as well. So okay, cool. And then just to give you a little bit of context, essentially what we're going to be doing is we're going to bake the information from that high poly model to the low poly model to save us on polygons while still having all the same amount of detail. So in order to kind of clarify that, I'm going to go to Display, Heads Up Display, Poly Count, and we'll be able to see what's going on here. See, so that floor underscore low is sitting right at around 64 triangles, and then that floor underscore high is sitting at right around 655,360 triangles. So obviously that's going to be a substantial savings. But so anyway, before we dig into that a little bit more, I want to talk really quickly about what kind of normal maps are doing. So if you're familiar with normal maps at all, I'm sure you've seen them. They look kind of like this. I just typed in normal map onto Google, and you can see there's a bunch of different examples of what's kind of a normal map. And this one is probably one of the clearest representations of what's actually going on here, which is that it's a representation of the way that the surface is actually varied from the actual geometry of the low poly. So if you see this image here, essentially it's going to be like there's kind of a green color on the top, there's red from the right, and then there's kind of this general blue toned color that fills out all the neutral areas. And so basically when a normal map is being read, it just looks at that specific pixel and figures out, is that pixel neutral as in unchanged? Is that pixel angled to the right? Is it angled to the left? Is it angled up or down? And it gets a corresponding color. So you can see that really clearly whenever you're looking at these with these kinds of circular kind of cone shapes, because you can see that anything that is facing essentially up relative to the texture has a green color, everything right has a red, and so on. And you can actually see that too here when you're looking at this one. That's kind of an example of like a faceted face, because you can see it's like a green, it's kind of a cyan, purple, and kind of an orangish, and those get more extreme as the angle differences get more extreme. Now, one thing that's worth noting is that if you're comparing the idea of a normal map to a height map, is that a height map is not actually going to be producing the same types of results. So, for example, this image here of this importing a grayscale PNG and using it for height map to create kind of noise or other types of effects in geometry. This is actually affecting geometry. And if you're familiar with game development, you'll know that height maps are actually what are used to create terrain tessellation. So these are kind of a more advanced version of the type of thing that a normal map can do. Normal maps cannot perturb the shape, but they can affect the lighting direction. And so what ends up happening is having a shape that's actually getting modified like this ends up being closer to the rendering overhead of the actual complexity of that model, but has the advantage of using a shader effect to optimize the way that that is created or represented. Whereas a normal map actually makes the model render much more efficiently while doing a slightly less significant change to the surface. So without further ado, let's go ahead and quickly jump into Maya. And I want to show you an example of just basically to help you understand the kind of color representations. So here, what I've done is I've put together a scene with my high poly model. So this is the one that has all the high density detail. And then what I've done is I've just set up 3 different lights. So I'm going to quickly open up my attribute editor so you can see it. So this light is set to blue, and actually if I wanted to, I could make it like slightly duller, or I could make this technically the half blue, which is the one that that is normally used in normal maps. But just for the case that we're describing here, I'm just going to leave this full blue just so it's a little bit clearer. And this is the one that's actually aimed directly from the top down at the model. Then there's the green light, which is actually coming essentially from this side over, from basically from it's going along the z-axis, and then the excuse me. And then I just set up a red, which is doing a similar thing except across the other axis. And if we wanted to represent this even more accurately, I could do the additional colors for the inverse. Like I could do the opposite of red and the opposite of green and so on. But for right now, I think that this is a helpful illustration because what you can do is if you just look directly head on at this model, because it's a flat model, you can actually see something that is kind of similar to what you would actually see once the normal map is baked, even though it's actually in the 3D geometry, and this is just showing where the light hits it, right? So basically this is showing where the difference would be in the lighting information versus like a flat plane. And I sometimes find that that's helpful to represent, just to give more information. So okay, so that's good. I think we're good with that. So let's actually jump into setting up a model so that it can be used to create a normal map. So first thing is you want to make sure that you actually set up UVs, and I'm going to do UVs in a more naive way first. Then I'll show you a problem that occurs, and then we'll resolve it. So first off, I want to go ahead and just quickly hide my floor. So I'm going to hit Control H. I'm my floor high poly to hide the floor high poly. I want to go to the floor low poly. And what I'm going to want to do is set up UVs for this, because normal maps and height maps and all that kind of stuff will not work if the low poly doesn't have UVs. However, it is important to note that if the low poly has UVs, the high poly does not, under basically any condition, need UVs, because you're not using the UVs for creating a normal map. You're just using the low poly UVs. The high poly is based on the object itself. So let's go ahead and quickly lay out some UVs so that this looks a little more natural. I'm going to do something which might be the most obvious. So I'm going to right click and select face. I'm going to grab these little top faces, and I'm going to hit Shift greater than, just so it expands the selection around there. And then I'm going to go ahead and go to UV planar options. I want to make sure I have best plane selected, and I'm going to select keep image width height ratio. That's a good way just to make sure that it's going to project the most accurate shape. Then I'm going to go ahead and hit project, and that'll give me a little bit of a piece of the top down here. And if I want to see what that looks like, I can also toggle on the checker pattern. And so I can see what the resolution looks like, and I can see that there's some problems here, but we'll get that all sorted out. So I'm going to turn off the checker so I can actually see what's going on. I'm going to turn on the shaded view here, which is over on the far left of the menu, just so I can see it more clearly. And then I'm going to select another side here, and I'm just going to quickly planar map this as well. So I'm going to go to, you can go to UV planar, and this time you don't have to select the options because you previously set the options. And then if you don't make anything else selection, a different tool usage, you can just hit the G key, and you can quickly planar map each of these sides. So I'm going to hit the G key, select each of these with the Shift keys, and then G to planar map these. And then the last bit is actually the underside, and I'm going to make the decision that actually, because the underside is probably never going to be seen, I'm just going to go ahead and select those faces and delete them. Now these UVs are all overlapping, and this is actually very bad because you do not want to have overlapping UVs in order to generate a normal map, even if there are some situations where you could make textures where that would work correctly. So what I'm going to do is I'm going to select all these UVs. I'm going to go to Tools, or I'm sorry, Modify. Go to Modify. And I'm going to select Layout Options. I'm going to select Unfold 3D, which will help me there. I might want to select Fixed Non-Manifold Geometry. That may or may not be relevant depending on your model. Then I don't need to worry too much about the packing here. Under shell pre-rotation, I usually want to select either horizontal or vertical, because that means that all of the objects will align in a way that is very uniform, and then I can make edits manually. So I'll do like horizontal. Shell pre-scaling, you want to select preserve 3D ratios, because that means that all these pieces will be scaled so that they actually keep the same size relative to each other, and most of the time that's going to be what you want to do. I'm also going to check the box for rotate shells, just because that gives it a little more flexibility. And then the last bit is I want to make sure that I have a little bit of shell padding. In this case, I have a 1024 map is the plan, so I'm going to go with a shell padding of maybe like 8. I could go with 16 or various numbers. Really, you want to have enough shell padding that if you start doing MIP maps down to lower levels of resolution, it doesn't start pulling from other parts of the texture until it gets low enough resolution that you wouldn't see it. Okay, so then I'll go ahead and select layout, and that looks pretty decent. I think the only thing that I want to do is I want to make sure that I'm actually optimizing this a bit. So what I'm going to do is I'm going to double click on this UV shell here, shift double click on the next UV shell. Then I'm going to go to transform, and I'm going to click the rotate 90 degrees, so it says 90 set here, or by default. I'm going to hit the rotate, and I'm just going to move this up to here, and then I'm going to grab all of these, move them roughly to the center, hit the R key to scale, and then just kind of move these, maximize this a bit so I can make sure I'm using as much of the space as possible. So my goal is I want to get it closer to the edge as I can without going over. Actually, one nice little trick for that is if you turn on the checker pattern, it'll show you if you've gone too far. So you see if I scale and it actually starts showing another UV quadrant, that's an indication that I've actually gone too far. But if I can position it where that's not the case, then I'm probably just in pretty good shape. So I'm just gonna have to scale this a tiny bit. Okay, there we go. I'm gonna turn off the checker pattern. And as you can see, that looks like that's pretty good coverage for this texture. I could probably double click here, shift double click, slide these a little bit just so there's a slightly more uniform spacing. And then honestly, that should be more than fine. And then what I want to do is I want to go ahead and I want to actually bake my normal map. Now remember we talked about the fact that we want these to be directly on top of each other. You also want to make sure that your high poly is not hidden because it needs to actually be visible in the scene. So if you hit Shift H, that will unhide selected objects. I can probably close out the UV editor now. I'm going to select the floor low poly. And then I'm going to switch from my modeling tab to select the rendering tab. And then here, this is where you can access the Maya normal mapping tools that are available natively in this package as opposed to the ones that are available in external packages. And again, a lot of people probably will not use this if they have a more advanced workflow like Substance, but it is a good idea to know how this works. So we're going to go to Lighting Shading, Transfer Maps. And what you want is you have a target mesh, you have a source mesh, you have an output map, and then you have information about the Maya common output. So I'm going to go through and really quickly explain each of these and what they do. This should not be too difficult. By the way, if you wanted to make a height map, that would be called a displacement map, and you could do that here. So if you wanted a height map, you could create that as well, but I'm going to focus primarily on normal maps. So first off, we've got the target mesh. Target mesh is supposed to be the low poly shape. What that means is you are taking things from the high poly, which is the source mesh, and you are applying it to the low poly, which is the target mesh. So I have my target mesh selected here. If you have the wrong one selected, you can select, say, clear all, and then I could select the low poly and add selected explicitly. Normally, it will select whatever you had currently active as your selection when you open this window and make that the low poly. And it should be noted that you can actually add more than one object, so you don't have to have just one object, but it is often a little bit easier to bake one object at a time. Okay, so then for the source mesh, we want to go and select the floor high poly. So I'm just going to select that floor high and select add selected. You'll see that floor high shape there. That indicates that you're on the right track. Now there's a couple of options here, such as display and search envelope. These might be a little bit counterintuitive at first, but the way that it works is basically this envelope is used to search out a certain distance from the low poly model in order to find the information from the high poly model. And if the envelope is cut off, chances are it actually won't capture everything from the high poly. And this is relevant in most tools. Sometimes it can actually just be an explicit number, like a length that you set. But in a lot of cases, it's actually this envelope expansion. So I want to switch the display from mesh to either envelope or both. And then I want to just move the search envelope out so that you can see it, and you can see that it fully captures the high poly. So I can see that there's a little bit of a section here that it sticks out. And so I can type in a value, like if I type in 2, okay, that's not quite. Maybe I could do 2.2, not quite, 2.3, something like that. And then basically all I'm checking for is that I don't see any spots bleeding through. Now you want this to be as tight as possible, because if it goes really far out, the projection actually just becomes massively less accurate, and that's not what you want. So, okay, so I'm going to go ahead and click on normal. And then this lets me set information about what I'm creating. So I'm going to click on the folder here where it says normal map, and basically this is just where you're setting your location for where you're saving the normal map and what the name is going to be. For now, I'm just going to save it to my desktop. And while I'm in here, I'm also going to select Targa, which will be the type of texture format I'm going to use. There's a lot of reasons for targas. I can explain that at some other point in the future, but in general, targas store the best amount of information in general, and you have the most control over the channels on a targa, so it's usually the best one to use. So I'm going to call this floor_normal, save. Then the file format is there. I actually usually uncheck include materials. Now you can decide whether or not you want to do that, but I think in general it's a good idea to uncheck include materials. This is often something that produces an error, such as, like, say if you baked a normal map already onto a model and you need to rebake the normal map, if you include materials, it will actually take the normal map that's applied to the model and then apply a normal map that was baked on top of what was already represented there. Now, in some cases you may actually want to do that if you were trying to, say, combine normals, but in general, most of the time, if you have include materials turned on, you're going to get effects that you didn't actually expect, and it kind of slows down your workflow. So, okay. And then the last bit, we can go to connect output maps to shader. And this means, like, so if you already have the correct material on your low poly, you can select assign to material. Otherwise, you can select new material. I'm just going to have new material for right now because I just want it to show kind of basic results. So, and then then we want to go to Maya common output, and I just want to change the size to 1024 by 1024 because I think that's a good texture size. And then the sampling quality, I'm not going to do this right now for this demo, but you want to use either probably high if you're actually making your final final render, but it will render substantially slower than if you're using the lower quality. So for now, I think low is fine because I just want to be able to get through this as quickly as possible so we can make iterations and I can give you some feedback. So I'm going to not select bake and close because I want to leave this map, this window open. I'm going to select bake. And you'll notice that there's actually a little display at the bottom of the screen that shows the progress that you're making on your current bake. So it says it's at 39% right there, 42%. It usually goes pretty quickly for normal maps. For other types of maps, it sometimes can take a little longer. Ambient occlusion maps tend to take longer to bake than normal maps, for example. Okay, and so now we've completed the bake. We probably won't see anything particularly interesting right away. So I'm going to take my floor high, and I'm going to just quickly hide that by hitting Control H. And then I just want to hit 6 on the keyboard so that it will actually display the normal map that we created. And just minimize that transfer maps window. And okay, so in general, this actually is going to look pretty good. And I don't really have too much to complain about with this normal map. It actually came out looking pretty nice. The model looks pretty accurate. If I quickly unhide the floor high poly, so Shift H, and just move this over to the side. They have a slightly different color just based on what their default materials are. But overall, I mean, this is pretty good. It's a pretty similar visual representation. And again, this one has 600,000 polys, and this one has like 56, right? So obviously there's a huge benefit that you get out of that. And it's also worth noting that we didn't make this piece 100% fully flat. It still has some geometry in it so that it matches the high poly. But I want to make sure that this is like a really comprehensive lesson then, and that you can come away feeling like you know how to solve common issues and artifacts in normal maps. So let's take a look at something that's actually not good here. And correct that, and then we'll see. We'll just sort of talk about what goes into making those decisions. So let's go ahead and move that floor high poly back. So I'm just going to hit 0 on the translate X, Control H, and if I zoom in on my floor low poly, and I get like really, really close, like say in the middle right here. And then I click off of it. What you'll notice is that actually there's this kind of weird artifact. Basically everywhere that there was kind of an actual polygon edge here. And this is a common thing that actually becomes more and more serious as the resolution gets lower. And it's a very straightforward why it's actually happening. But we can kind of visualize that and see what's going on. So I'll show you the 2 different ways that you could fix this, and then we'll move on from there. So let's go ahead and take a look. I'm going to go to my attribute editor really quick. I'm going to go to my new material. I'm going to go find my bump mapping, and then I'm going to select View to view my texture. And if you'll notice here, like at each of these corners, you'll actually see that there's kind of a weird color distortion, and it's actually more pronounced the more actually much more pronounced even just looking in the normal map itself than it is just looking at the final asset. And that's because normal maps are a combination of 2 factors. UVs and smoothing groups, in addition to it reading information from your high poly. So what it's trying to say is I'm going to look at a section of the object surface based on the smoothing group that it has, and I'm going to say relative to that smoothing group, what is the actual angle change from that high poly, from the low poly to the high poly. And then I'm going to write that to the UVs. And so what happens here is that if you look right in these sections where there are these kind of additional details here, like these kind of weird divots, it's basically because that's what that model actually looks like there. It's got a hard edge. And so each of these hard edges is actually having a separate piece of information written for it about how the normal map is supposed to be offsetting the relationship of that color and feedback. So the initial thing that you'll notice is that there's definitely a point where the color value for this side is not the same as the color value for this side. And the color value for this top is not the same as the color value for the side. And so there's going to be about at least 1 pixel width of error right in that position. And so there's basically 2 ways to solve this. We're talking about every hard edge will essentially have a shading difference between parts of this normal map. So one thing that we could do, and this is often the right way to do it, is to just separate our UVs. So if I open up the UVs here, I could do this kind of like a quick and dirty way, where I select all of these edges here. So if I right click and select edge, I could select all of these inside edges, and I could select cut and sew and select cut. Then I could grab the UVs here, select all these UVs, scale them down just a tiny bit, and then basically just start separating these away from each other just ever so slightly. So I could double click on this, slide it up, double click on this, slide it up, maybe slide it up and out. You can select each of these and just start trying to, basically separate them from each other. And you'll notice that on this particular model, it's kind of a tedious endeavor to try to do it this way, because the model is almost totally flat. It's just got this one artifacting effect. So let's, I'm just going to try to do this as quickly as I can, just to show you kind of like what happens in this context. And then we'll talk about another way that we can try to tackle this. Okay. And you'll notice I'm kind of going outside the lines a little bit here, but I will come back and I will resolve that shortly. Okay. And then I'm just gonna, slide these back a bit. Probably want to move this one. I'm gonna grab these, move them out a little bit. Okay. And so in general, the reason that we're doing this is because it eliminates the 1 pixel width of error that gets produced by having those faces basically existing on different planes. And this is something actually in a lot of cases is the right thing to do. It's not necessarily in this case, and we'll show why in a second. So let me go ahead and quickly rebake this so that we can prove that it works. So I just need to grab all these and make sure I've scaled it down so that it all fits inside the 0 to 1 range. Okay. And you'll be able to see that I'm not lying once we do this. So if I go back to the transfer maps dialog, unhide my high poly, Shift H, and then I can just bake this again, so I can just hit bake. And it'll bake for a few seconds. And then I can hide the high poly real quick. And you'll notice that the issue is much less pronounced. Now, there are still some spots that I probably just had a little bit too close. But in general, you'll notice that you get a massive reduction in the visibility of what you're seeing. And so I think, for example, right here, I think I probably just should have separated that area a little bit more. But the thing is that when we're talking about this, we've got to remember that we're always talking about smoothing groups. And so in a lot of cases, it's not reasonable to just separate more faces. And the only thing that you really need to separate for the purpose of normal mapping is where you actually have a hard edge. So if there's something that you would likely want to project as a single UV map with no separations or cuts, you could just make sure that they're all part of the same smoothing group, which is something you might remember from earlier. So I'm going to go ahead and jump back to this. First off, I want to make sure that I've actually sewn up these edges. So I'm going to select all these edges here. Just quickly. Yeah, it looks like that's actually the one that it looked like it still had some problems. I'll just quickly do this. Now I could just go and like re-planar map it, which would be fine too. But I just want to show how we can do this. And also grab these. Okay, so I've grabbed all those edges. I can go select so. And just for right now, that should be fine. We can live with that. And then what I want to do is I want to quickly I'm going to turn off hardware texturing. So I'm going to go to shading and uncheck hardware texturing. And then I'm going to select edge. And I'm going to go basically select all of the edges that are currently hard. So in this case, it's all the edges are roughly on the inside here. So it's going to be all these. And I can actually do this a little faster by just going, like, I can grab, for example, the faces in the middle, control, right click, two edges, select two edges, and then just expand the selection. And then I can just grab these four edges in the middle, and that'll be good. And then what I can do is I can go to switch back from my rendering tab to my modeling tab. I can select mesh display, soften edge. And then what you'll notice is essentially I have the best of both worlds here. So this entire top face is just all smoothed together, which matches the fact that it has only one UV section. But then the sides are actually hard edges because they're a very extreme angle. And so I just can make sure that that UV actually has those separated. So I will do the separation where it's relevant, and then I will do combining smoothing groups wherever it's not. And so then what I can do is I can just unhide my high poly. All of my settings are still retained from before, so I can go to bake. Probably looks like it's doing a little faster, so. And then I can go ahead and hide my high poly, hit 6 on the keyboard again to turn back on the hardware texturing, and then you'll notice that basically that issue has been totally eliminated. Now, there are some really steep angles where you can still be aware of the actual 3D shape, but you have to be exceptionally close in order to see that. And this is something that, like, it actually took me a really long time to realize this, and I had to actually, like, ask friends for help, and we did kind of like a cabal where we put our brains together and tried to figure out why those weird artifacts were happening. And once we realized it was like, oh, of course, it's writing one pixel with two values from two different sides. So in general, this is the kind of thing that you're going to want to do when you're creating a low poly with a normal map from a high poly. Is you want to make sure that your UVs are set up so that they have separations anywhere that you have a hard edge. You want to have smooth edges anywhere you know that you have your UVs create a large continuous shape. You want to make sure that your high poly is overlapping with your low poly, and you also want to make sure that you are setting a search envelope that captures all of the high poly. And then beyond that, really everything is pretty self-explanatory. This is a really important process to know. I can say that most professional game developers and a lot of professional filmmakers, depending on what kind of projects they'll be working on, will be using normal maps and baked displacement maps and all that kind of stuff for their workflow. So by understanding this, when you go into more advanced software, you can also know why things do or do not produce a good result. So hopefully you guys liked the video and it provided some useful content. I will see you in the next one.